In Lesson 4, we're going to continue looking at functions that take in parameters. However, this time we're actually going to take a look at functions that take in more than one parameter. And we're also going to dive in and take a deeper look at what's actually happening when we make function calls and we return values back to our main function. By the end of today's lesson, you should be able to write a function in Python that takes in multiple parameters. So before I move on, just make sure that you know these basic pieces of terminology. Remember that a function is like a mini program. It basically is a subroutine or a method or a mini program, whatever terminology you want to use, that has a small job. And structured programming is this concept of breaking a program up into functions, basically breaking it up into smaller tasks and smaller problems to help us solve a big problem. A parameter is a value that is sent into a function, and a return value is sent from the called function back to the main, or back to the function that actually called it in the first place. So it's sending that value back. So we've talked about these the past couple of lessons. These are what you should know so far. So before we talk about functions with multiple parameters, we're going to talk about what happens in general when we send a parameter into a function. So that means when we have something like area, and then we have radius, and we're sending in this radius, what's actually happening is the main function just sends in a value. Now, you're probably thinking, duh, Miss Wardecki, but what you need to note is it's not sending in this entire variable. It's sending in just the value of that variable. So it basically looks at radius, finds the value, and sends the value. That's the only thing. So what happens is if radius is a variable up in the main function, this function of area can't actually see it. It only knows I was passed this particular value, and I'm going to use this value to complete my task. So something to note is that Python sends these parameters by what's called value. It just goes in, says radius is equal to 17, and it sends 17 in that spot. So keep that in mind. It is not sending the entire variable, name and all, into the area function. It's just sending the value. So what I'm going to do here is break this down just a little bit more by using those functions that you see on the screen. So you can see here we have our main function as well as a double function. The main function is where the majority of our code is running, but it calls the double function whenever it wants to double the name. So because we have two functions, what I like to do is split it up and say, okay, these are where all of my main variables are going to go. Then I separate it from all of my double variables. Okay, so we have two different functions which will have two different sets of variables. So now I know that my main function is where most of my program runs because I can see that right here. The main is my main source of code. So here it starts off and it gets the name from the user. So I'm going to make a variable called name inside of main, and let's say that they enter in the name Laura. So name starts off equal to Laura. Then from here, once it gets the name from the user, it calls the double function and asks the double function to do its job. Now here we have a variable name in here, but remember, we're really only passing by value. So what we're doing is we're taking the string Laura and we're sending it into double. We're not actually sending in the variable name. So right now, here we have double and it's taking in a string named Laura. So what's happening here is that name inside of double, so notice I have two variables called name. These are two completely separate things. There's name in main and name in double, and they actually represent two completely separate variables. This is the concept of passing by value. So down here in double, name changes to Laura to start, because that's what's sent in, and as it's sent in, it's set equal to right here. And then from here, name is changed to name times 2. So this changes to Laura, Laura. So notice here that inside of double, name is changing. Inside of main, name is not. So notice we have those two variables, and depending on what function we're working in is where that variable is actually changing. There are two variables called name, but one in each function, so they are different. Then from here, the last piece, and I got to erase a little bit on the bottom so I can show you the output. The output of this function happens whenever we print. So at the end of double, we print name to the screen. So we're inside of double. We're going to print double's version of name, which is currently set to Laura, Laura. So we're going to print Laura, Laura to the screen. And then once we're completely done here, this jumps right back in where we left off, and it's going to print name, but this time note we're in the main function. So when we print name from the main function, we're printing what name in the main function is currently equal to, which would be Laura. So this gets a little bit confusing, especially if you have multiple variables with the same name, which is perfectly fine and commonly used when we're working with functions, but just keep in mind that name in main and name in double are two separate variables. So this slide right here just recaps what we discussed with the previous chunk of code. We have our main program with its version of the name variable. Then we had our subroutine, which in this case was called double, and double had its own memory area with its own name variable. So each function stores its local variables in different places in memory, which means double's variables are in a totally different place than main's variables. They are two separate functions. So because we had two variables called name, one in each function, there's actually a name variable saved twice in memory, and your computer understands which one to look at based off of which function it is currently working in. So just keep that in mind as you work. If you have a name variable in main and a separate name variable in a different function, they are saved in different locations in memory and will change at different times depending on which function you're currently working in. So the types of variables that we saw on the previous screen are called local variables. And they're called local variables because they are local to the function that they are defined in. So for example, in the main function, we had a variable called name. That variable was local to main, while in the double function, we had a variable called name as well, and that was local to double. And essentially, these can only be accessed by their function. So what this means is that name in double can only be accessed by double, and name in main can only be accessed by the function main. So what's tricky here is sometimes we want to share variables between different functions, and this is where this concept of parameter passing comes in. So to access a variable outside of a function, it must be passed to that function via the parameters, which is why when we called double, we passed by value by we put name on the inside, and we were able to pass that variable's value inside of it. Now, if you're still kind of a little unsure about local variables, I always use the bubbler as an example. So if you haven't heard of a bubbler, that's okay. But bubbler is what we call a drinking fountain where I grew up in Wisconsin. It's basically because the water bubbles out, but this is what we called it over on the east side of Wisconsin. Now, to everyone else in the country of the United States, they don't know what this is. This was local to my area. It was a term that was local to where I grew up, and you only really knew what it was if you were from that area. That's this concept of local variables. Main is where this variable of name is known. It's kind of like my bubbler. And double is where this variable of name is known. Essentially, all the functions from the outside can't see what these values are. And the only way that they can is if this function itself or somebody from that area shares what that value of name is via parameter passing. So I know that's a little weird to think about, but that's what a local variable does. It is local to its function. It can only be changed by its function, but the functions themselves, they can share what that variable value is by using parameters. So here's where we're going to dive in and talk about multiple parameters for a function. So here you can see that we have our definition, we have our name, we still have our parentheses, but the only difference here is that we have multiple parameters that are separated by a comma. So we have parameter 1, comma, parameter 2, comma, parameter 3, comma, however many parameters we need. So these function definitions are pretty much the same. We just have parameter 1, comma, parameter 2, comma, parameter 3, comma, parameter 4. Now, the tricky part here is that order does matter, because the order that you list these in are the order that you want the user to call your function with. So for example, if you have name and then your function call with your parameters on the inside, you want to make sure that they're inputting those values in a way where you can actually use them. So for example, say we were finding the area, let's do area of a trapezoid. Now to find the area of a trapezoid, you need height, base 1, and base 2, and they work differently in there. So if we do height, base 1, base 2 in our definition here, then when they called this function, they would have to enter in, okay, wherever their height was, wherever their base 1 was, and wherever their base 2 was. They would have to enter them in that particular order. So order does matter. But it's kind of nice that we can easily add in multiple parameters. You do 1, 2, 3, 4, 5, however many you need, and then when you call that function, you just list the 1, 2, 3, 4, 5, however many variable values you need, however many parameters you have, that's how many you list, and you list them in order. And then just to reiterate, a copy of the value of all the different variables are passed into the function. The function then will create its own variables with those values, and they will be local to their function. So a couple of key things to remember from this lesson before we trace through code and write an actual program is that when Python comes to a function call, now that we've dealt with functions a number of times, the calling function, which in our case is mostly the main, suspends execution. So it's going along, it gets to a function call. It stops. And then what happens is that the formal parameters of that function get assigned the values supplied by the actual parameters. So for example, say we called and we had the area function and we sent in a height of 4, we sent in a base 1 of 6, and we sent in a base 2 of a variable entered by a user called base 2. What would happen is we would take these actual values and we would set them equal to the formal parameters listed in the definition. So definition had height, base 1, base 2. So what happens is these formal parameters, height gets set to 4, base 1 gets set to 6, and let's say that base 2 was previously set to 10 already, so base 2 gets set to 10. It gets set to all of those values. Then from here, the body of that function is executed, so all of the statements inside of area would be executed, and then when this ends, it will either just jump right back to where it started, or if it returns a value, and that depends on the function, then it will return the value right there where it was called, and once that value is returned, if it's being saved somewhere, it will save there in your main calling function, and then it will move on with execution, just right after where that function call happened. So what we're going to do here is we are going to just trace through a couple of examples so that you get the hang of how functions actually work. So here I have to add in a piece of code because I never actually set x equal to anything, and I'm going to set x equal to 10 to start. And then from here, what I notice is that I have two functions. So I'm going to have main variables saved in this chunk of code, or this chunk of space, I'm going to have my change x, that's my other function, saved here, and then I'm going to have my output over here. So the first thing I see is that in main, the variable x is changed to 10, so it starts at the value 10. Then I have a very long print statement there. I'm just going to do main x before to shorten it up a little bit. And main x before, if I have x here, x is currently set to 10. So that's what x in the main before the function is called is set to. Then from here, the function change x is called. So remember what happens is it suspends execution and it moves down here. And we take change x's variable x and we change it to 10. So 10 is being sent in here. And then we print, we'll do change, sorry that got a little sloppy, change x at the beginning. It's set to 10. Then we see we have x equals x plus 25, so this becomes 35. Then we have change x at the end is now set to 35. Now because I've reached the end of this, I now jump right back to when change x was running, but right after. And then I continue on with execution, so it says print the main value of x in main. So we have main x after, and so I go into main and I look at x and it's still 10. So notice that the main value of x is not changed as a result of change x running. Only change x's variables can be changed by change x. And last example here, so I can see that I have a main function that's going to have variables. So I'm going to put those there. I then have a compute area function. So I'm going to put those variables there. And then I have an output function, or output area. So from here I have length width that I'm getting from the user. So let's say that we sent in 6 and we sent in 5. So we have length, which starts at 6, and width, which starts at 5. And then area, this is where we have a function call happening. So we're right here, we suspend execution, and we're going to go into compute area, which is down here. And what happens is as we go in, the value for length, which is currently set to 6, is aligned right with L, because notice how they're in the same location. So L becomes what length is currently equal to, which is 6, and W becomes what width is currently equal to, because it's in the second position, and it becomes equal to 5. So notice that we took the actual parameters here and set the formal parameters down here equal to them. Then from there, we go inside and run the statement. So I have A, which is equal to length times width, so 5 times 6, which is 30. And then I'm returning A back to the program. So as this ends, it's sending this value for A back right in place of here. And because I have this equal sign, in main, I'm going to save that value of 30. I'm passing that value of 30 back. I'm going to save it in area as 30. And then the last thing I do is I print area equals, and I go into main and I look at its area, and I print 30 to the screen.